topic of bonding. We just did binary ionic compounds, and today we're going to look at something called ternary ionic compounds. Now the thing about ternary, ternary ionic compounds, they contain ions which are called polyatomic ions. Polyatomic ions. Alrighty? Now the thing is, guys, we know the prefix poly means many, right? Now what happens with polyatomic ions? There's more than one element, stuck together, normally covalently, and it acts as a unit carrying a charge. So for example, classic example, OH minus, which we use a lot in acid-base chemistry, right? The O and the H are bonded together, and the whole unit, this guy right here, carries a negative charge. So the negative charge is not exclusive to the O. Also, if you have something like phosphate, PO4 minus 3, this whole unit carries a charge of negative 3. The negative 3 is not exclusive to the oxygen, So it's more than one atom bonded together carrying a charge called a polyatomic ion. So here's the deal, guys. When you have a ternary compound, you're going to have at least 3 or more different elements in the compound, No problem, so you recognize it. The good thing is, folks, you have your handy-dandy reference table, So you're going to use table E with this anytime you recognize that you have a ternary compound. Binary, bi, just 2. Ternary, you're going to have 3 or more different elements in the compound. If I can just adjust this properly, I'll be happy. All right. See. Okay, looks good. All righty. So what are we doing again? We are doing the crisscross method, okay? So here we go. Now, aluminum and sulfate, The Al is plus 3. The sulfate is SO4 minus 2. Now, it's basically the same thing as binary, but the thing is, guys, if this number going over to the polyatomic ion, if it's greater than 1, you must put a parentheses around the polyatomic ion. That's a major difference between binary and ternary. So, what do I mean? This 2, just the 2 goes to the Al, so you're going to get Al2, Now this 3 goes to the SO4. Now since this number is greater than 1, it's a 3, you put a parentheses around the SO4, like that, bam, put a 3 outside, and you're done. That's it, you move on, okay? So once again, anytime the number going over to the polyatomic ion, if it's greater than 1, you put a parentheses around the polyatomic ion. You don't put a parentheses around monoatomic ion, guys, just polyatomic, okay? Alrighty, so let's do this one right here. We have barium, which is Ba2+, okay? And we have sulfate, SO4 minus 2. So we can look at it and see that these 2 is going to cancel out, But let's just work it out. We're going to get Ba2 parentheses SO4, okay, parentheses 2 on the outside, But we know from experience we're supposed to put these formulas in the simplest whole number ratio possible, So what's going to happen? This 2 and that 2 cancel out, and you're left with what? You're left with BaSO4 as your final answer, and you're done, okay? Alrighty. Now this guy in the bottom right here, if you can see this guy, this is between the ammonium and the sulfate, alright? So what's going to happen is, you're going to get NH, alright? You're going to get NH4+, Now what's going to go to this NH4+, this polyatomic ion? The 2 from the sulfate. So we need a parentheses around this ammonium ion. So polyatomic ion, guys, okay? If you're not sure, check table E, alright? So the 2 goes there, bam, okay? Now guys, this ammonium, it's only plus 1. So the 1 goes to the sulfate, but we don't have to put a parentheses around the sulfate. So we're going to get NH4 parentheses 2, SO4, you're done, okay? Alrighty, so moving on. We have Al and plus 3 and PO4 negative 3, So when you crisscross, what's going to happen? The 3's will cancel out. So all you left with is ALPO4. Okay? no problem. Ba plus 2, PO4 minus 3. The 3 goes to the Ba, the barium, all right? So you're gonna get Ba3, all right? Now the 2 goes to the phosphate, right? So you're gonna get parentheses, PO4, all righty? And you're gonna get a 2 on the outside, and you're done, okay? Notice, once again, as we said in the binary examples, there's no charges here, right? It's understood the first guy is a positive ion. It's understood the second guy is a negative ion. We're just balancing the charges by switching the numbers. Alrighty, so you have NH4 plus and PO4 minus 3, okay? So the NH4, right, gets the 3 from the phosphate. So you gotta put a parentheses around this polyatomic ion. 3 goes there. Now remember, NH4 plus is only 1, right? So the 1 goes to the phosphate. It doesn't need a parentheses. You go PO4, okay, and you're good to go. Bam, that's it. Let's do the next guy, okay? We're doing Al plus 3, right? And this guy over here. Now, ladies and gentlemen, if you see this guy looking like this, CR207 like this, don't make up a crazy name. Okay, sometimes students do that. You put dichromium, no. It's a polyatomic ion. The name is there for you on table E. The form is there for you on table E. Don't make it overly complicated, all right? No problem. So, what are we switching? The 3 goes to this guy right here, this dichromate, okay? And the 2 will go to the Al. So you're gonna get what? Al2, right? Now the 3 that's going to the dichromate, we need a parentheses around it. So you put CR2O7 parentheses 3, bam, done. Okay? Alrighty. Next guy, Ba plus 2 and CR2O7, 2 negative, right? So we have positive 2 and a negative 2. What's going to happen to those 2's? They're going to cancel out, right? So simply, you're going to put Ba, okay, CR2O7. One more thing before I move on. I said before, right? You could never, ever change the subscripts of polyatomic ions. PO4 is here, PO4 is there, PO4 is there, PO4 is there, CR2O7, CR2O7, right? Notice it stays the same. The only modification you can do to polyatomic ion in this topic is to put a parentheses around it. That's it. But don't change anything about the original subscripts of a polyatomic ion. Okay? Alrighty. Next one is NH4 plus with the dichromate. The 2 goes to the NH4. Polyatomic ion is NH4. So he needs a parentheses around him. Bam. So the 2 goes there. The dichromate is getting a 1 from the NH4. So he's going to be, bam, CR2O7. Alright? Done. Alrighty. Moving on. Let's see if you can see this one over here. And okay, make sure I get everything inside. Alright, so you got Al plus 3, right? And this guy right here. Now, ladies and gentlemen, this guy right here has 2 different ways of writing it. This is called an acetate ion, people. It's polyatomic ion. There's this C2H3O2 minus, and there's the other one, okay, which is, let me find something right here. It's CH3COO minus, right? Okay, if I remember from my memory banks. Okay, it is right here. Okay, so it's different ways. You only choose one of them, folks. Don't feel you have to put both of them. So if I like this one, I like to use this one. There's no problem. You can use the other one. But when they say acetate, right, use either one, no problem. All right, don't use both. Okay, so Al plus 3 and this whole acetate guy right here carries a charge of just -1, right? So the 1 goes to the Al, so you're gonna get Al, all right? And the 3 from Al here goes to the acetate. So you must put a what? You gotta put a parentheses around the acetate. So it's gonna be Al, parentheses, C2H3O2, okay, whoops, parentheses, 3, all right? Okay, moving on. We have Ba plus 2, all right? And the acetate ion. 2 goes to the acetate, the 1 goes to the Ba, so Ba stays as is, Ba, all right? Now, since the polyatomic ion acetate is getting a 2, it needs a parentheses, all right? You put a parentheses, C2H3O2 on the 2 on the outside. And last one, guys, last one is the ammonium ion, okay, with the acetate. Ammonium is +1, acetate's +1, so it's gonna be nice and even and simple. You put them together, NH4, that's a 1, so we don't show anything. And the acetate's 1 also, C2H3O2, and you're done. Okay, guys? Now, I'm gonna make another video, right, on how you name these guys, but I'm just gonna give you a preliminary, let's do a couple right here. I'll make another video naming these guys, okay? So, no problem. All right, so I'll give you a preliminary look. All right. So, AlPO4 is aluminum phosphate, and you're done. Just write that down. Aluminum phosphate. Alrighty? Then, BaC2Cr2O7. Now, what do? You look at it. You got Ba in it, chromium in it, oxygen in it, right? So automatically, that's 3 things. You know you must have a polyatomic ion somewhere. Look on your reference table, right? Table E. Cr2O7 is your dichromate part. Ba is your barium part. And as always, guys, the first guy, the positive ion, stays as is. So you write barium down. Alrighty? Barium. Okay, and what's Cr2O7? Dichromate. You write it in. Dichromate. Okay? Alrighty, let's do a couple more. 2 more maybe. Alrighty, so let's do this guy over here. Okay? We have aluminum. Alright, we have aluminum, and we have this 1, 2, 3, 4 different elements in it. You don't panic. You say to yourself, there's 4 different elements. There must be a polyatomic ion in it. I'm going to look on table E to see what the polyatomic ion is. It just so happens that the C2H3O2 part is called acetate, right? So what do? You don't panic, you write acetate down, and the first guy is aluminum, so the name will be aluminum. Okay, acetate. Notice as we finish, right, you're not making up dicarbon, trihydride, no. It's a polyatomic ion. Look on table E, their name's right there. You're good to go. Take care. All right.